Thanks, Matt. Hi, everyone. I'm Chris Yang, VP of Engineering at Corporate Travel Management. Thanks for having me today. So today I'll be talking about AI and personalization, how we could use AI to differentiate and optimize your product. All right. So we've seen an uptick in online transactions, and it's easy to say that COVID has accelerated the shift of brick and mortar retail to e-commerce. As the online shopping space become increasingly crowded and competitive, brands and retailers need to better understand their customers' need and create new ways to serve them. As we enter this fighting phase of recovery, personalization will be key in winning customers and market shares. So today, I'll be addressing the evolution of personalization engine and the application of artificial intelligence. I'll be covering the machine learning process along with the use of artificial neural network and classification. So traditionally, marketers use role-based or persona-based personalization to deliver experience specific to target segments. Campaigns are scheduled ahead of time without the ability to learn and adapt on the fly. As opposed to relying on predefined marketing campaigns, modern personalization engines engage customers at the moment of opportunity. Some studies even show that marketers only have roughly 5 seconds to inform its target audience, customers, before they get distracted. So the next gen of personalization is about learning contextual situations and making real-time predictions. The goal here is to deliver authentic, relevant, and hyper-personalized content and messages that deepens the relationship between brands and their customers. You can't really accomplish all that without investing in customer data and analytics solution. Moreover, to succeed in today's marketplace, it becomes ever more important to deliver a consistent experience across all touchpoints. Customers today expect that their journey to be seamless across different channels. The ability to provide personalized experience consistently will be a key competitive advantage going forward. And finally, we need to create individualized experience at the enterprise scale. While you could provide tailored concierge service at a per customer level, it can be challenging to offer such experience to tens of thousands of customers at the same time. So how do we turn the future into reality? Machine learning might be your answer. Machine learning can pull and analyze large sets of structured and unstructured data and use algorithms to train and build accurate, high-precision models that can identify customers' behaviors. Machine learning fits functions to examples. It uses that particular function to generalize and make predictions against unseen data. With the rise of cloud infrastructures, we can now train, evaluate, and deploy models faster than ever before. Trained models can be deployed into various applications, including mobile devices, to make at-the-moment and just-in-time predictions at scale. So here is a standard machine learning process incorporating AutoML. AutoML stands for Automated Machine Learning. AutoML to select and fit an initial model. So let us look at it from a high level. I'll be going each step in greater detail in the subsequent slides. So first, we need to gather all the relevant data from various sources and inject them into a data lake. Then we can start assessing the shape of the data. In the next phase, we clean, rescale the data to fit a standard distribution. Then we use AutoML, automated machine learning, to help us determine the best classification models. Again, we use classification model very frequently for personalization. AutoML fits sample data set against all available algorithms in the library to come up with the best candidate models. And we split the full data set into training, validation, and testing sets. And in the next step, we'll use the training We'll use the training set to train models and the validation set to select the best model. And throughout the process, we'll use the associated hyperparameters to yield the best result. And finally, we'll test the best model against the testing sets. As long as everything looks good, we'll then deploy it as a web service, which can then be consumed by any mobile web applications. So let us walk through each step. So where do we locate the initial data set? So transactional data, transactional records is a good place to start. They're probably the most reliable. These could be customers' purchase history. We could also leverage digital analytics from various channels, including web and mobile. Also user research, which is the voice of customer or the explicit customer feedback from surveys or reviews, findings from previous A/B testing, and any relevant third-party data you can find. And once we've loaded the relevant data sets, we need to understand the relationship between them, learn what features might be useful. This process is commonly referred or known as the exploratory data analysis, or EDA. And next, I cannot stress the importance of having quality data in performing machine learning. You all heard the phrase, right? The phrase garbage in, garbage out, right? It's particularly applicable in this case. The preprocessing step here involves removing duplicate records, imputing missing values, which requires to determine whether the null data is missing at random or missing in a systematic way, because this will have an impact on how we treat the missing values. Rescaling categorical variables such as gender to numerical values so they can be easily understood by the computers. Anonymizing the PII, personal identifiable information, and dropping the obvious outliers. And finally, extracting features to fit a baseline model. Next, we need to split up the data into 3 different sets. Training sets, which is used to train the model, and the validation and testing sets, also known as the holdout. They're used to evaluate the effectiveness of the trained model against unseen data. We want to see how well the models perform on unseen data. The validation set is used to select the best candidate model, whereas the testing set is used to assess the readiness of the final model before we deploy it to production. So you could pick whatever numbers you feel necessary, but at the minimum, you need to have at least 60% of training data. In this case, we split it into 3 buckets: 60% training, 20% validation, and 20% testing. Next, baseline model fitting. Traditionally, model selection is the most time-consuming step of any machine learning process. It is resource intensive and requires significant data science domain knowledge. So in this new process, we'll leverage AutoML, or automated machine learning, to train and build models with high scale and efficiency. So behind the scene, AutoML runs many machine learning pipelines to compare the sample data set against all available algorithms in this library. It helps determine the best classification model in this case. Obviously, AutoML can be used for like regression or time series forecasting as well. But today we're using it for classification. I've taken an example from Azure. So to create an AutoML run, all we need to do is import the data set, configure the compute resource, and specify the primary matrix, the validation type, and task type. And in this case, we pick classification with K-fold cross-validation. On the next screen, I show the run took about 25 minutes to complete. It picked the light GBM, which is light gradient boosting machine. This is a type of gradient boosting algorithm. So once we determine the candidate model from AutoML, we'll need to evaluate them with different hyperparameters. So in this example, we use Grid Search CV from scikit-learn to fit the model. So we select a neural network as our algorithm. Again, you could choose any algorithm provided by AutoML with high enough accuracy and precision. So we've considered three key hyperparameters in this case for neural network: the activation function, the number of hidden layers, and the learning rate. And it turns out that the best neural network model uses RAU activation, which stands for rectified linear unit. It sets the floor to 0, so any negative number will be treated or converted to 0. So this model also uses adaptive learning and has 100 hidden layers. Now, sure, you can see with this, you're getting roughly the 80.3% accuracy. So what exactly is a neural network? In simple terms, it's just a series of connected nodes. In this example, we look at a specific type of neural network called the multi-layer perceptrons. This feed-forward network consists of input, which are your features to make final prediction. Next, we have a number of hidden layers in between. Each node represents a function or a logistical expression or regression. Each function will fit the parameters with slightly different weights. Hidden layer 1 will determine the relationship between the input variables. Hidden layer 2 takes the result from layer 1 and perform a conditional analysis. Finally, we arrive with a final prediction by aggregating the prediction from the different branches. And finally, we test our best model against the 20% testing set to ensure accuracy and precision. The final model can be published and deployed as a web API endpoint. Its response can be freely consumed by any mobile devices or any web applications. I'd like to show an example from Azure Machine Learning here. Again, there are various comparable ML cloud providers out there like AWS, IBM Watson, or GCP. And in this architecture, data are collected, shared via Stream Analytics, and stored in a Cosmos DB or a NoSQL database. A data factory task is then set up to orchestrate this. It pulls from the Cosmos DB, transfer the data, and store the data set in either a data lake or a SQL data warehouse. It's now called Synapse. Azure Machine Learning Service, it can now access the full data set. We then use Jupyter Notebook, which we've shown previously, to run our data science project to clean, prune, and extract the features. The scikit-learn library will help us fit and score the models. And finally, as mentioned earlier, we'll deploy the trained model as an API endpoint. To sum it up, ML is an incredible tool that solves many hyper-personalization challenges today. It allows marketers to collect real-time data and proactively engage customers with personalized content and messages, and at the right moment. That's very important. AI-based personalization is the marketing approach of the future. And when set up correctly, it increases brand loyalty and helps drive your funnel conversion. Thank you for your time today.